Hello everyone and welcome back to my channel. This is the A+ Tutor. Today we're going over solving derivatives using the power rule, product rule, quotient rule, and chain rule. So if you haven't watched my last video on finding derivatives using the difference quotient, go ahead and check that out. I'll have it linked above and you'll find it in the description below. But we learned that the derivative of a function can be found using the limit definition, which means the derivative of a function f prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x over h. We don't always have to use this limit definition in order to find our derivatives. There are some rules that we can follow that will make it really easy to solve for the derivative of our function. Starting us off, the first rule we have is the power rule. So the power rule says that when a variable is raised to a power, the derivative of the function will be that power times the variable raised to the original power minus 1. That means if we have f of x equals x to the n, then our derivative, f prime of x, will be equal to n times x to the n minus 1. Basically, we take this n and we bring it down, and then we subtract 1. That's all we're doing whenever we take the power rule. So for example, if we have f of x equals x to the fourth, then our derivative, f prime x, will be equal to 4x to the third. We would bring our 4 down and then subtract 1, which gives us 4x to the third. Next, we have our multiplication by a constant rule. That says if a function is multiplied by a constant, then the derivative is the value of the function's derivative times that constant. So if we have some c times f of x, then our derivative will be c times the derivative of that function. So for example, if we have y equals 7x squared, then our x squared is our f of x, and our 7 is our constant. This means we can say y prime is equal to 7 times f prime x, and f prime x, we just learned from the power rule, will be 2x to the 1 power. So our y prime is equal to 7 times 2x, or 14x. Next we have our add and subtract functions rule. When we add or subtract functions, we can find the derivative of each individual function and then take that sum or that difference. So if y equals f of x plus or minus g of x, then y prime will be equal to f prime x plus or minus g prime x. For example, if we have y equals x squared plus x, then our x squared is our f of x, and our x is our g of x. So f prime of x will be 2x from our power rule. G prime of x will be 1 because the derivative of x will just be 1. Again, from our power rule, because x to the 1 will be 1 times x to the 0, and x to the 0 is just 1, so we're just left with 1. And that means our y prime will be equal to 2x plus 1, the sum of our derivatives of our function. Next, we have our product rule. The product rule is when you're multiplying two functions together, the derivative of that entire function is the derivative of the first function times the original value of the second, plus the original first function times the derivative of the second function. So it looks something like this. If y equals f of x times g of x, then y prime will equal f prime of x times g of x plus f of x times g prime of x. For example, if we have y equals 3x times the square root of x, then f of x would be 3x, g of x would be the square root of x, or x to the 1/2 power. This way we can use the power rule. So f prime x would be equal to just 3 because the derivative of 3x is 3. And g prime x, using the power rule, would be 1/2 square root x. We'll do some more practice later on how that math works, but essentially that's what that would be if we worked that out. So what that means here is that y prime is going to be equal to the derivative of our first function times our original second function, plus we hold that first function times the derivative of our second function, which is 1 over 2 square root x, or this is equal to 3 square root x plus 3x over 2 square root x. Next, we have our quotient rule. So our quotient rule is when we're dividing two functions. The derivative of that entire function is going to be the derivative of the first function times the second function minus the first function times the derivative of the second function all over your denominator squared. So if we have y equals f of x over g of x, then y prime will equal the derivative of our first function times the second function minus the first function times the derivative of the second function all over our denominator squared. For example, if we have y equals x squared over 3x plus 4, well, my numerator is going to be my f of x, and my denominator is my g of x. So if f of x is equal to x squared and g of x is equal to 3x plus 4, f prime x equals 2x, that's from the power rule, and g prime x is equal to 3, also from our power rule, and then our add and subtract functions rule. So our derivative then becomes y prime will be equal to the derivative of f of x, which is 2x, times our g of x, minus our original f of x times the derivative of g of x, g prime, which is 3, all over 3x plus 4 squared. And then this can be simplified, this can be reduced, all of that, but that's how we set up our derivative and how we solve for y prime. Last, we have the chain rule. The chain rule says that when you have a function within a function, the derivative of that entire function is the derivative of the outside function times the derivative of the inside function. So if y equals f of g of x, then y prime will equal f prime g of x times g prime of x, or the derivative of our entire function, keeping our inside the same, times the derivative of that inside function. So for example, if we have y equals 2x minus 1 raised to the third power, well, our f of x is going to be the entire thing, which is, let's call it x to the third, and our g of x is going to be whatever's on the inside, which is 2x minus 1. So f prime x is, using the power rule, 3x squared, and g prime x, using the power and then our add and subtract, is going to be 2. So this means our y prime is going to be equal to 3 times our g of x, which is 2x minus 1 squared, times the derivative of 2x minus 1, which is 2. Or we can simplify this, and we would get 6 times 2x minus 1 squared as our derivative. So these are the 6 rules that we use when we solve derivatives. There are some common derivatives that I'm going to go over now that we can use to really easily and quickly find our derivative, but in general, when we're solving derivatives, these are the rules that we want to use. Here are some common derivatives. Let's start with our constant function. So the constant function is y equals some c, so then the derivative of that is equal to 0. For example, if y equals 7, y prime equals 0. If y equals 25, y prime equals 0. And we know this is true because our derivative is the slope of our function at any point, and the slope of a horizontal line is 0. Next, we have our linear function, and we're considering the parent function here. Y equals x is our linear function. that means y prime equals 1. Or if we add a slope, y equals ax, so our derivative y prime will always be equal to a. Again, the derivative is the slope of our function. So if we had something like y equals 2x, then y prime would equal 2. Next, we have a squared function. So this is something like y equals x squared. This means y prime, using the power rule as we just saw, the power rule means we'll bring this to the front and then subtract 1. So y prime will be equal to 2x to the 2 minus 1, which is 1, or just 2x. So for example, if we have y equals 3x squared, then y prime would be equal to 3 times 2x, or 6x. Next, we have our square root function. So this is y equals the square root of x, and keep in mind that we can rewrite this as y equals x to the 1/2 power. So we're going to use the power rule again. That's going to come to the front, and we're going to subtract 1. So this means y prime is going to be equal to 1/2 x to the negative 1/2, or that's equal to 1 over 2 times the square root of x. Anytime we're taking the derivative of the square root of x, it's going to be equal to 1 over 2 times the square root of x, based on the power rule. Next, we have an exponential function. So here, our exponential function is y equals e to the x, or y equals a to the x. So when we're talking about the natural base e, the derivative of y equals e to the x is itself. Y prime equals e to the x. So that's something that we're just always memorize, we'll always remember, and always use that whenever we're solving the derivative of e to the x. Now when we have some base raised to the x power, some e to the x, our derivative y prime then is going to be equal to a to the x times ln a, or the natural log of a. So for example, if we have y equals 4 to the x power, then y prime will be equal to 4 to the x ln 4. And then we have our logarithm functions. So if we have y equals ln x, or y equals log base a of x, then y prime will be equal to 1 over x for our natural log ln x, and our derivative of our log is y prime equals 1 over x ln a. So for example, if we have y equals log base 7 of x, then y prime will be 1 over x ln 7. Now let's look at our derivatives with our trig functions and our inverse trig functions. So starting with our trig functions, we have y equals sine x. So the derivative of that is going to be cosine x. When y equals cosine x, the derivative of that is negative sine x. And when y equals tangent x, remember this is equal to sine x over cosine x, so we can use the quotient rule to solve this, but when we do that, we would find that y prime equals secant squared x. So what's nice is if we know the derivative of sine and the derivative of cosine, we can find the derivatives of all other trig functions, whatever we need, using our rules that we saw earlier. So knowing the derivative of sine and cosine will give us everything else. But if we memorize these derivatives for our trig functions, we can save a lot of time by not having to go and do the work. So we don't stop at just sine, cosine, and tangent. We also have our reciprocal trig functions. So when y equals cosecant of x, cosecant is 1 over sine. And again, we could use the quotient rule, but our derivative is going to be equal to negative cosecant x cotangent x. When y equals secant x, this is 1 over cosine. Y prime will be equal to secant x tan x. And last, when y equals cotan x, which is cosine over sine, 1 over tangent, or cosine over sine, then y prime is equal to negative cosecant squared x. Then we have our inverse trigonometry. So for these, there are only 3 values that we'll consider. Y equals sine to the negative 1 of x, y equals cosine to the negative 1 of x, and y equals tangent to the negative 1 of x. Or you may see this written as arc sine, arc cos, and arc tan. They are the exact same thing. So for the inverse of sine or arc sine, y prime is equal to 1 over the square root of 1 minus x squared. For the inverse of cosine, our y prime is equal to negative 1 over the square root of 1 minus x squared. And for our inverse of tangent, our derivative is equal to 1 over 1 plus x squared. And these are our trig and inverse trig derivatives. Now let's get into some examples of solving derivatives using these derivative rules. So first we have y equals 4x to the fifth minus 5x to the fourth. So when we're solving these derivatives, we're going to find that we need to use a combination of these rules in order to find that derivative. No one rule is always going to give you the whole thing. Let's look at what we'll be doing here. First of all, we've got two functions that are being subtracted from each other. So we have f of x minus g of x, which means this is rule number 3. Y prime will be f prime x minus g prime x. So we can start with that. We know that f of x is equal to 4x to the fifth, and g of x is equal to 5x to the fourth. Now we'll use our power rule and constant rule. So our power rule says that we're going to bring this to the front and then subtract 1. So these derivatives will become f prime of x. That constant is going to stay out front, and we'll multiply that by 5x to the fourth. And for g prime of x, same thing, that constant is going to stay out front, and then our function becomes 4x to the third. So f prime of x will be equal to 20x to the fourth, and g prime of x will be equal to 20x to the third. So when we put it all back together, we get y prime is equal to our f prime of x, which is 20x to the fourth, minus our g prime of x, which is 20x to the third, and that's our final answer. Next we have y equals e to the x times sine x. Here we're going to use the product rule because we have f of x times g of x. And that means our derivative will then be f prime x times g of x plus f of x times g prime x. So if f of x is e to the x and g of x is sine x, then f prime x, if we remember from all of the common derivatives that we talked about earlier, f prime x is equal to e to the x. The derivative of e to the x is e to the x. And the derivative of sine x is cosine x. So let's solve this derivative. Y prime is going to be equal to f prime x, which is e to the x, times g of x, which is sine x, plus f of x, which is e to the x, times g prime x, which is cosine x. And that's our final answer. Now we have y equals x squared minus 1 over x. So here we're going to use the quotient rule. We have f of x over g of x, and that derivative is f prime x times g of x minus f of x times g prime x all over g of x squared. So for this example, our f of x is going to be equal to our numerator, which is x squared minus 1, And our g of x is going to be equal to our denominator, which is x. F prime, we're going to use the power rule, so we're going to bring that 2 to the front and subtract 1. So f prime will be equal to 2x, and the derivative of any constant is 0, so we don't have anything at the end. And then same thing here for g of x, there's an invisible 1 on top. We bring that down and subtract 1, which means g prime x is equal to 1x to the 0, or just 1, because anything raised to the 0 power is equal to 1. So now we can solve our derivative by plugging that into our definition based on the quotient rule. Y prime will be equal to f prime x, which is 2x, times g of x, which is x, minus f of x, which is x squared minus 1, times g prime x, which is 1, all over g of x, which is x, squared. So now we can start to simplify. This isn't our final answer. We want to make sure we simplify as much as possible to find our answer. So this is equal to 2x squared minus x squared minus 1 times 1 is just going to be x squared minus 1 all over x squared. So we can distribute that negative sign. We get 2x squared minus x squared plus 1 all over x squared. And now when we simplify this, we get y prime equals x squared plus 1 over x squared, and that's our final answer. Next we have y equals 3x squared times x to the third plus 1 raised to the 7th power. So here there's definitely a few different rules that we're going to use. First of all, we've got the chain rule with this x to the third plus 1 all raised to the 7th power, and we have the product rule because we have 3x squared times this other term. So this actually looks something like f of x times g of h of x. So here we're going to use the product rule, and then over here we're going to use the chain rule. So we know for our product rule, y prime will be equal to f prime times g of x plus f of x times g prime x. And then for our chain rule, our derivative will be equal to g prime of h of x times h prime x. So let's find all of our individual derivatives so that we can put this together. F of x is equal to 3x squared. G of x is equal to x to the 7th power, and h of x is equal to x to the third plus 1. So all of these actually are going to be the power rule. We're going to bring that to the front and subtract 1. So f prime x is going to be 3 times 2x, or 6x. For g of x, we're going to bring that to the front and subtract 1. So g prime x is going to be equal to 7x to the 6th power. And for h of x, again, bring that to the front and subtract 1, and then the derivative of any constant is 0. So h prime x is going to be equal to 3x squared. Now we can use all of this to solve our derivative. Our full derivative, if we combine our product and chain rules, will look like y prime equals f prime of x times g of h of x plus f of x times g prime h of x times h prime of x. So we know what each of these individual components are, and we can just plug them in. Y prime will be equal to f prime x is 6x times x to the third plus 1 to the 7th power, plus our original f of x, which is 3x squared, times g prime of h of x, 7 times x to the third plus 1 to the 6th power, times h prime of x, which is 3x squared. And now we can simplify. So this is going to be equal to 6x times x to the third plus 1 to the 7th power, plus 3 times 7 times 3 is going to be 42. X squared times x squared is x to the 4th. And then what we have left in our parentheses, which is x to the 3rd plus 1 raised to the 6th power. And that's going to be our derivative. For our next example, we have y equals 2x minus 4 over the square root of x. So we're going to be using our adding and subtracting functions here and our power rule. So we have f of x minus g of x, and that becomes f prime x minus g prime x. F of x is going to be 2x, and g of x is 4 over the square root of x. But we can actually write that as 4x to the negative 1/2 power. Whenever we have values in our denominator where the variable is in our denominator and not in our numerator, it's usually better to bring that up and use a negative exponent so that we can make solving that a little bit easier, because now with the exponent like this, we can use the power rule. So for f of x, we've got this invisible 1 here. That's going to move up front and we'll subtract 1. So f prime x will just be equal to 2. And if we remember from earlier, some of our common derivatives, y equals ax, y prime would equal a. That's exactly what this one is here. Same thing, we're going to bring this negative 1/2 up and subtract 1. So g prime x is going to become 4 times negative 1/2 x to the negative 1/2 minus 1 is 3 over 2. Or we get negative 2 over x times the square root of x for our g prime of x. So now we know our derivative will be f prime x minus g prime of x. So y prime is going to be equal to f prime, which is 2, minus g prime, which is negative 2 over x square root x, or y prime is equal to 2 plus 2 over x square root x. Now we have y equals ln x to the 7th power. So this is going to be a chain rule because we have y equals f of g of x. So f of x is ln x, and g of x is x to the 7th power. So f prime x is going to be, that's one of our common derivatives where the derivative of ln x is 1 over x. For g prime x, we're going to use the power rule, and we're going to bring that 7 to the front and subtract 1. So g prime x will become 7x to the 6th power. Y prime will be f prime g of x times g prime x, which is coming from our chain rule definition. So if we plug in all of our values, y prime is going to be equal to f prime g of x, so 1 over x to the 7th power, times 7x to the 6th power here. And we can simplify this. So if we put these on top of each other, we actually have 7x to the 6th over x to the 7th. And our x's on top will cancel, and we'll be left with 1x in our denominator. So our derivative is actually equal to 7 over x. Now we have y equals x to the 3rd times the 5th root of 2 minus x. We can actually rewrite this as x to the 3rd times 2 minus x to the 1/5 power. This typically makes using the power rule a little bit easier because it's very clear to see what our power is. And this is another case where we have the product rule and the chain rule combined. So our expression looks something like y equals f of x times g of h of x. So we've got these 3 components that we have to work with. F of x is equal to x to the 3rd, g of x is equal to x to the 1/5 power, and h of x is equal to 2 minus x. So to find the derivative of f of x, we're going to use the power rule, bring that power to the front and subtract 1, which means f prime x equals 3x squared. The same thing will be true for g of x. We're going to bring that power to the front and subtract 1. So g prime x will equal 1 over 5x to the negative 4/5 power. 1 over 5 minus 1 is negative 4 over 5. And then for our h of x, we have our constant, and then we have our linear function, y equals -1x. So just whatever our coefficient is will be our derivative here, and h prime x will be equal to -1. And our derivative of our product and chain rule will be f prime x times g of h of x plus f of x times g prime h of x times h prime x. So if we plug in our values that we just found, y prime will be equal to f prime is 3x squared times 2 minus x to the 1/5 power plus f of x is x to the third times 1/5 times 2 minus x to the -4/5 power times -1. So we can simplify this, and we can write this as y prime equals 3x squared times the 5th root of 2 minus x minus, because we've got that -1 that we're multiplying, x to the third over 5 times the 5th root of 2 minus x to the 4th power. So we can rewrite that 4/5 as 2 minus x to the 4th power, all of that under the 5th root. And because it's negative, it ends up in our denominator. So this is our derivative. And finally, our last example, and this is another trig example. So we have y equals secant squared x times tangent x. And this is another one where we've got a chain rule and a product rule, even though it may not look like that is the fact in the first place. Because we have the secant squared x, we've got a function inside of another function. Because we can write this as y equals secant x squared tan x. And now it's very clear that there's a function inside of a function. So this is f of g of x times h of x. F of x is going to be x squared. Our g of x is our secant x, and our h of x is our tangent x. So f prime x, we're going to use the power rule. We'll bring that 2 to the front and subtract 1, and f prime x will be 2x. G prime x, this is one of our trig derivatives, so this is one that we'll want to memorize, and this is equal to secant x tangent x. And then the derivative of tangent x is secant squared x. So when we take our derivative of our product and chain rules, we'll have f prime g of x times g prime x times h of x plus f of g of x times h prime x. So plugging in all of our values, we have y prime equals f prime g of x to secant x times g prime, which is secant x tan x, times h of x, which is tan x, plus f of g of x, which is secant squared x, times h prime x, which is also secant squared x. So simplifying this and multiplying this out gives us y prime is equal to 2 secant squared x tangent squared x plus secant to the 4th x. Thank you so much for watching. I hope you enjoyed and I hope you learned something. If you liked this video, give it a thumbs up, and if there's anything else you'd like to see, if you had any questions, or if you want another video of just examples of derivatives, leave a comment down below. Let me know what you guys want to see. Also, make sure you're subscribed to my channel so that you never miss a video. See you next time.